Know that?
Sure.
No? I hate doing it to you. I really do. But I am probably going to be gone Friday all day.
Where is the day you're going to go?
I cannot tell a lie. I'm going skiing.
That's right. You just have to take another personal day.
No, I actually wasn't planning on this. I don't really. I mean, I want to now, but I didn't want to. It wasn't something I wanted to do. My sister is turning 60. And she's in very good shape at 60 years of age. She's never been married. She, works out. She's a multimillionaire. She just, she's really cool. She does all kinds of cool stuff. And so she wants to spend her birthday with me and my kids. And so she just reached out to us, and she's taking us helicopter skiing. It's like, wow, okay.
Yeah, you can't miss that.
You can't miss that.
We'll be okay
It's like, okay, teach class, go helicopter skiing. I'm like, I think I'll go
Yeah,
helicopter
we'll
skiing.
be okay with the video.
Yeah.
I don't know if this is like too personal of a question.
Yeah.
But like, your siblings, are they all like very like affluent? Like, did you guys all?
No, it's not a personal question. You're cool. Are
Like,
they all
are you all
affluent?
doing like really well in it, or like?
So
some
my parents were
siblings?
married 6 times between the two of them, and so we all either have a different mom or a different dad.
Okay.
And so, dude, that looks so good, and I'm starving. You're killing me, Smalls.
Sorry.
No, yeah,
What
sorry.
burger is that?
It's not a burger, it's a torta. It's from a Casa de Ocho.
Nice.
Oh,
Where is
nice.
that?
So, we're all kind of at different levels in our financial situations. Yeah.
Just like one thing of your life. I was just wondering.
What's that?
I just said that's just like one aspect of life,
No,
I
it's
just
cool.
wondering.
No, and some of us are members of the church, some of us are not. So
We'll get those ones that aren't a member of the church members.
yeah, it's I can't go Satan's plan on them, so I can't force them. So we just do the best we can. You just love people. That's one thing is I'm kind of one of these people that I love people, and I probably just learned that in my life because, I have a lot of different people in my life. And you love them for who they are, But one thing I'll tell you that was really cool in New York is one of my interesting experiences there is I was really surprised at how nice everybody was. I thought they'd be kind of like, I've heard, stories about, just New Yorkers being, kind of gruff and, rude and stuff. They're all super cool, super nice, man.
Really?
I loved meeting the
Are
people there.
you being sarcastic?
No, I'm not. I loved meeting the people there. It was such a hoot. And then our first day there, we went to an Italian restaurant. Super good food, famous place. Like there's all these pictures on the wall, all these famous people, and stuff, and very authentic. And our server, he was this good-looking kid, and I literally just thought we got there, and this is like the first person that I'm interacting with in New York, really. We got there, we took the red eye, we got there early, got to our hotel, and then just took a nap because we were just wasted, Then we got like, hey, let's go get some food, and then we were gonna head to Times Square and do some things, and we actually went to a play that night and stuff. But we go to this restaurant, and this guy's our server, and I mean he is clean cut. Now don't get anything I'm saying wrong here, all right? I mean he's just he's got a little bit of a facial hair, but it's so clean cut. His hair is just kind of short and clean cut, and he looks like a BYU Idaho student.
Oh, really?
And he's super nice. I mean, he's got no piercings, he's got no tats, nothing, and I'm just like, this isn't New York. I'm back in Rexburg, like this kid's like so clean cut and stuff. And he's just this really nice kid, right? And I'm like, you could be a Mormon, man. And so he's talking to us, and we're enjoying him, and we end up deciding to just kind of chill out, and we end up talking and eating and hanging out for about an hour and a half there. And we got him kind of involved in talking to us, which, more than the average server will spend time with. He spent quite a bit of time telling us about his life and stuff, and he was a great kid. I'm like, I gotta like do some missionary work with him, because like I just think this kid, I just was having these impressions. So I got his, Instagram and his email and all stuff, and it was so crazy is, there's almost 10 million people in New York City. Okay? There's almost 10 million people in New York City. And that's just the ones that live there. You take all the visitors and everything. I mean, on any given weekend, I mean, you have 20 million people, you know, coming in and out of the city. So we leave on Monday morning. We get up at 3 o'clock in the morning, pack our bags, have to catch a taxi and get over to the airport by 6. And we get over there and we check in, we go through TSA, all that stuff, and there's not a ton of people in the terminal where we're going. I turned to my wife, I'm like, yeah, we should probably hit the bathroom before we go, you know, get on our plane. She's like, yeah. So we stop, and she goes to the bathroom. All of a sudden I hear his voice like, no way. And it's our server, and he's in the airport. You know, you look at the odds. I'm going to 20 million people, right? All the people that exist, and there he is again. I'm like, okay, this is meant to be. And he even felt that way too. He was just like, man, you know, I don't know. It's just really cool experience. You know, just met lots of neat people. It was fun, man. I dug it. I dig New York. I think that's cool.
I found out that like people from New York don't care. Like
they don't care
like so.
About what?
I mean, like about like just like nice comments and all that stuff. Like this chick, she had the same shoes that I had.
Yeah.
Like the same like Adidas like all stores, and I was like, hey, nice shoes. Nothing.
I
was like, what? Okay, no big deal.
Well,
I'm of
sorry,
course
man.
not a terrorist. No, I'm just playing.
All right, look at this word on the board. Polynomials. What does this word make you feel like? What does it make you feel like? I don't want to know intellect here. I want to know feelings, emotions. What is this word polynomial? What does it elicit in you? Indifference. Okay. Anything else?
Many of a kind.
That's a definition. I want to know emotions. Does this elicit anything? Polynomial. Nothing?
No.
Awkward.
Awkward? Indifference? What's that?
I don't know how to describe it.
You know how to describe it? Okay.
It's a feeling.
You know, a lot of people, when they see big words in math like differential equations and polynomials and multivariates and things like that, they're intimidated a little bit. They're a little nervous. It creates a little anxiety. Like, what are we talking about? Okay, it's a big word. I told you before, I like breaking grammar down. Okay, what does the word poly mean? What does the word poly mean?
Many.
Many. Yeah, absolutely. Many. Very good. And so, nomial. Does anybody speak French? Parlez-vous français? Anybody?
Number.
Bonjour.
Yeah. Un petit peu. Okay.
Okay.
What is the word nom? N-O-M in French.
Name.
Name. Very good. Okay. And so, the science of giving things names, like naming stuff. It's like we're the first cave people. It's like ooh. Table. Sure. Whatever. I don't know. Well, giving stuff names is called terminology. Okay, the science of giving things names is called terminology. So literally translated, polynomials means many terms. And sometimes if you can break something down like this, like, okay, we're going to study a chapter about many terms versus we're going to study a chapter about polynomials, just seems less, intimidating. Agreed? Yeah? Okay. So what are we covering in chapter 4? Well, you were supposed to watch some videos and do sections 4.1 and 4.2. Did this work out for you? Was it hard? Were you able to handle it?
Incredibly easy.
Yeah.
Just towards the last part of 4.2 of your video, that was getting a little hard for me to understand.
Scientific notation?
And a lot of it, I couldn't see the board either as well.
Really?
Good to know.
Yeah.
I had to look pretty close because it was like
Yeah.
angled.
I
Angled a
couldn't
little
tell. Yeah, I couldn't tell what numbers you were putting up there. A lot of
Oh, really? Now, could you zoom in, though, on your screen?
Not on mine.
It was just a little blurry.
I could
Like it
zoom in.
was.
The
Good
far
feedback.
range.
We got to remember this.
I
'Cause
remember
we're
that.
making another video today.
You have
Okay.
a quality thing on YouTube. You can pick higher quality, but I don't know.
One thing we'll want to do is maybe just focus on
We can
This
have it
board.
closer.
Yeah,
Or
just
the
this
videos.
board right here, and then just erase and put it back up. So we just, instead of moving across, or if I go to that board, you could move the camera.
Yeah,
Yeah.
I think what would be best is to do it on another board and have him move
Yeah.
to the.
Yeah,
Cool.
I can do that.
I could see like the numbers, but because it was sideways, I couldn't see like the decimal point. And so
Ah,
Oh,
yeah.
decimal points.
Makes sense. Okay, so look up here. So sections 4.1 and 4.2 of chapter 4 is all about the laws of exponents and scientific notation. Okay? And then all the rest of this chapter is about polynomials. And we're going to learn about the basics of polynomials, how to add and subtract them, how to multiply them. Then in 4.7, we're going to review these principles. And then in 4.8, we're going to learn how to divide polynomials. So with polynomial, if we get into section 4.3, and I do want you to open up your text books or go to the Canvas link to this, because we are going to need you to look at something today. But I want you to go to page 335. If you look at section 4.3, if you remember, there's these little red boxes with letters in them that tell you, how, like if you have A, B, C, that means you have 3 different topics you're going to learn in that section. Well, in this section, we have what? Do you see this? How many letters do we have there? Or what letter does it go to? 4.3. Goes to I. A, B, C, D, E, F, G, H, I. Let's count that. A, B, C, D, E, F, G, H, I. That's 9 topics in one section. 9 topics in one section. That's a lot. The good news about that is, and I've told you this before, if you only learn one topic, it's going to be more difficult. But if we're going to teach you 9 things, they got to make them easy. Here's the cool thing. If you've never seen the word polynomial before in your life, okay, then this is even more intimidating today. But if you haven't seen it or heard it this semester, and you're like, oh, we're learning a new topic today, can I just tell you, I've been teaching you polynomials all semester long. I just didn't tell you they were called polynomials. So everything we do today, you already know how to do. Today's going to be very reviewish to you. And you're going to be like, wow, he called it this, but really, in polynomials, they call it something else. But we've already learned how to do this. We know how to do this. There will be a couple of small things, though, that will be new to you, but they'll be very small. Now, I've told you books are stupid. And, again, they don't let us down in section 4.3. Instead of making the most important thing first, they make it last. So we're going to talk about letter I to begin with. In the family of polynomials, there are monomials, there are binomials, and there are trinomials. I'll ask you, are there quadnomials, heptanomials, sextanomials, septanomials, octanomials? What do you think?
yes.
No. Okay? We're lazy. And anything with 4 or more terms, we just call it a polynomial. And we're going to be even lazier, and we're going to call them polys. Now, if you're Polynesian or have any Polynesian blood in you, okay, you could be offended because you'll be like, oh, this is my race, my culture. And let me tell you, the Polynesian people are way cool. And algebraic concept of polynomials is not cool, So for us to call these polys, it's just sick. But we're going to do it, okay? Because I'm lazy and I don't want to call them polynomials every day. I'm just going to call them polys.
Confess,
It's all good. What does mono mean? Mono. One. Okay, so monomial means what? One
Name or term.
term. There you go. One term. Binomial means
2.
two what? Two terms. Trinomial?
3 terms.
3 terms, right? And again, I said if we have 4 or more terms, we just get lazy and we call it a polynomial. And from this day on, we're going to call these polys, okay? Now I got a question for you. Okay? Is a monomial a polynomial? Yes or no? Okay, let me help you answer this question. What's my last name? Llewellyn.
Lewin.
Am I a Llewellyn? Am I a Llewellyn?
Yes.
Yes.
Am I a Rich?
Yes.
My first name's Rich, right?
Uh-huh.
So I'm both, right? Okay. Polynomial is like the family name. Everything's a polynomial. But if you're just one term, you're a monomial. It's like their first name, okay? And it's kind of like people in your church or your ward that have like 10 kids. And after like the third kid, you're like, I'm not fetching learning their names. It's a Llewellyn. It's a Smith. It's a Davis. Whatever you want to, you know what I'm saying? And that's where we go with the 4 more terms. Like, fetch it. You're just a polynomial. I'm not worried about this, okay? You good? Okay. Now, in part, we're not done with this. We're not done with this. We're going to come back. We're going to fill some stuff in here. But in part B of section 4.3, they talk about basically the terms of a poly, okay? And they're talking about how to identify the terms of a poly. And so we've already learned this earlier this year. We talked about how terms are separated by what?
Addition and multiplication, or division.
Plus and minus, let's do this. Plus and minus signs. And the sign before a term, what? Goes with it. Sign before a term goes with it. Okay, and we talked about this a long time ago. So look up here. Don't write right now. X squared minus 5x plus 6. That's a polynomial. How many terms are in this polynomial?
3.
So you could also call it a
Trinomial.
trinomial. So it's trinomial, it's also a polynomial ultimately. And there's 3 terms. What's the first term? What's the first term?
X to the square.
Okay, so your first term is x squared. What's your second term?
Negative 5x.
Oh, I love you. Negative 5x. And the last one? 6. Okay? And here's the deal. In part B of your homework tonight, they're going to give you a polynomial, and they're going to ask you to identify the terms in that polynomial. You're going to look up at the back of the book, and this is how they're going to write it out. They're going to write first, second, third. They're going to have x squared, semicolon, negative 5x, semicolon, and 6. Hard or easy?
Easy.
Easy. And you already know how to do this because we taught you this a long time ago, but we didn't call it
Polynomial.
polynomials. We just taught it to you, okay? So as to not intimidate you. Coming back here, knowing this now, look up here. And here's the thing, what is a polynomial? Okay, it's every term in math, okay? And so if I just have a number is a polynomial. 7, 2, 1, 0, 15. They're all polynomials. Or just a variable, x. Or put them together, 7x, or 7x squared, or 7x squared y, or 7x squared y over z. Now I got a question for you. Which ones of these move over into the binomial column? Which ones of these move over to the binomial column? Which one? Or
Ones
ones?
with y.
7x squared.
7x squared, that one?
It could be 7 times x squared.
Say it.
It's none of them. It's a trick question.
It's a trick question. It's none of them, fetchers. You see any plus or minus signs between these things?
Oh.
They're all monos. Monos, fetchers. Okay, look up here. X plus 7, 2x minus y, x squared, plus b. All of those are binomials, agreed? Yeah. X squared minus 5x plus 6, 2x plus y minus 4, a plus b minus c. Those are trinomials, agreed? Okay, you understand? All right, cool. Write it all down. Write it all down. Go, go, go. You're going to write, and we're going to take a little quiz today, so you got to write fast. What's up, Vines?
Are negative numbers polynomial?
Yeah?
Yeah.
Yeah, absolutely. Good question. Yep. Today, I want you to write. I want you to write all this down. Scribble, scribble, scribble. Go, go, go. Okay? When's the last day to retake the chapter 3 test?
Thursday.
Mañana. Tomorrow. Thursday. Yep. All right. While you're writing, I'm going to talk a little bit more. You guys okay with this for a minute?
Mm-hmm. Yes.
If it gets confusing, you can say, "Stop, Brother Rich." But it's not going to get confusing. So you're not going to say that. Because this is going to be easy for you. Because you know 95% of what I'm going to teach you. And that 5%, we're going to make you stop. Part A. This is what they call evaluate polys. again, in section 4.3, we're talking about the basics of polynomials, you know, how they're structured, their anatomical structure, you know, how we just, you know, kind of deal with them, but we're not talking about adding, subtracting, multiplying, and dividing them yet. What does it mean to evaluate a poly? If I tell you to evaluate the poly expression, so I'm just kind of curious, has anybody watched the videos other than this, you know, because you were required to watch 4.1 and 4.2 on video. I'm bummed to hear that you couldn't see things because we put some real time and effort into making those videos and making them really good. But I will say this.
They look fine to
We
me.
can see it, it's just not.
I will say this one thing though
Yeah.
to you, okay? And this is just being candid, okay? There are things that I can't watch on my phone. Okay? So if your phone is your tool, you're kind of taking your chances in putting your destiny into your own hands with that, okay? You get a laptop, you know? You got your laptop and you pull it up and you can expand it and, you know what I'm saying? You know what I mean? You can literally take it and go, whoop, and open up and spread that out and you know, see it. That's the one thing I tell you is, you know, if you're required to watch a video, you definitely want to get a better screen and then be able to, you know, increase your, you know, zoom capacity and your quality because your phone is really limited, right? All right. So if I tell you to evaluate the poly expression x squared minus 5x plus 6 when x equals -2, what do you do? What do you do in this? Look up here for just a second, everybody. What do I do here?
Plug -2 for x.
Yeah, wherever there's an x, we plug it in -2. Now, look at me. Are we going to write -2, look up here, are we going to write -2 squared or parentheses -2 squared? Which one?
Parentheses.
Yes.
-2.
Yes, because the x is touching that, and we're saying x equals this, so the whole value has to be in there. -5 times -2 plus 6. Well, -2 squared, help me?
-4.
How about +4? Negative and negative makes a positive, okay? Woo. I don't want to write on my shirt. Okay? Right, because it's going to be -2 times -2.
Yeah.
Because that's what we talked about before, right? -2 squared versus -2 squared. Remember that? The negative comes along for the ride. 2 squared is 4. So this is -4, where this one is -2 times -2, which makes +4. Remember that? Okay, cool. All right, so what about my next one? What's that? -5 times -2 makes what?
10.
Yes, we're going to have plus 10 plus 6. Well, 4 plus 10 is 14 plus 6 is 20. We're done. Hard or easy?
Easy.
Okay, let's look in your book for a minute. I want everybody to turn to page 335. So on page 335, you see, and if you don't have your book, you can get in Canvas. We've talked about this a bajillion times, okay? And you'll want to do this right now. So on page 335, you'll notice these first 11 problems, 1 through 11 odd, you know, they just give you these polynomial expressions. They tell you to plug in values, super easy. But then it turns into word problems. You're like, oh, fetch me, I got a word problem. Let's jump to the next page, 336, and look at problem number 21. It says, approximate the number of hearing impaired Americans of ages 20 and 40. Well, the problem is we have to have an equation to do that. Well, the equation is above it. Look at the thing that says hearing impaired Americans in blue, just a few sentences above. It says the number n in millions of hearing impaired Americans of age x can be approximated by the polynomial equation n equals -0.0000 6x to the third plus 0.00 6x squared minus 0.1x plus 1.9. Listen, folks, x represents what? Does it say? Age. And in this problem, they ask us to figure out how many hearing impaired people there are, that's n, when they're age 20. So where there's an x, we put in a 20, we figure that out, then we do it again, and we do it for 40, right? Hard or easy?
Easy.
No, it's easy, but I mean, those numbers are kind of gnarly. You know, I mean, you're going to have to make sure you don't make a mistake with your calculator. But it's all your calculator in you. You got me? You cool? Okay. All right, let's talk about the rest of these.
Okay.
So we've done A, we've done B. We're going to talk about C and E. C and E. Again, you could write while I am talking right now. C and E, it's really kind of weird. It's called collect. No, my bad. It's called identify. So one of them says identify like terms, and then E says collect like terms. And so we're going to call LT for like terms. but you and I have taught this as combine LT, which means combine like terms. And our tool that we use is the symbol method. We like to do that just for organization's sake. But one thing I want to help you take to another level is just kind of define LT. And an LT has the same variable and degree combo, okay? So look up here. If I have 2x squared plus 2x squared y squared minus 4x y squared plus 7x squared y. All eyes up here. Everyone watch this. How many terms do I have in this polynomial? How many terms?
4.
Okay, I got 4. Good job. Do I have any like terms?
Yes. Nah. No.
Is it another trick question?
Yes.
I have an x squared here. Do I have an x squared here?
No.
Some people say yes. No, I don't. Say, well, but that's an x squared. No, it's an x squared y squared because it's a single term, right? Separated by plus or minus signs. This is an x squared term. This is an x squared y squared term. This is an xy squared term. This is an x squared y term. They're all different. None of them are like terms. Are we clear?
Gotcha.
Okay. So if I put up here, minus 2xy squared, plus 12x squared y squared, do I have some like terms now? Yes or no?
Yes.
Okay. So do I have another term up here that's just x squared? Yes or no? You guys watch this. Let's do this together. Come on. Do I have another term all along there that's just an x squared term? Yes or no?
No.
So that's going to drop down to my answer, 2x squared. Okay. I have an x squared y squared. Is this an x squared y squared?
No.
No.
That's a minus. Is this?
No.
Is this?
No.
Is this?
Yes.
Ah. Okay. So I've got 2 and 12 make what?
14.
14 x squared y squared. You know what I like to do? I like to cross out the ones I'm not looking at anymore. Because now I'm only looking at 3 things instead of 6. Okay. I have an xy squared here. Is this an xy squared?
No.
Is this?
Yes.
Yeah. Okay, and these two combine to make what?
Negative 6x squared.
Negative 6xy squared. And then these are gone, and that doesn't even have a like term, so it's just 7x squared y. And you're done. You cool? Okay. A, B, C, E. Let's talk about D. D. All right?
Jimmy sausage.
D. D is, oh, yeah, this one's good. Identify, in fact, you know what? Yeah. This is identify the coefficient of, now let's put each term in the poly. Okay? So, first of all, do you guys remember what a coefficient is? I told you once.
It's the number in front of the variable.
It's the big number in front of the variable. Very good. Okay? So I'm going to write a problem up here. We'll put 12x to the 5th minus 4x squared plus 2x minus 7. Okay? In fact, let's just do plus x minus 7. How many terms are in this polynomial? Everybody, 1, 2, 3.
3.
4.
How many?
4.
There's 4.
Because the x.
What is the coefficient of each one? Let's go fast. What's the coefficient of the first term?
12.
Next one.
4.
Negative
4.
1.
1.
Negative
12, negative 4, 1, negative 7. Okay, cool?
Cool.
Hard or easy?
Easy.
Okay, so A, B, C, D, E, F. Let's drop the F bomb. Okay?
Ventures.
Fetchers. Amen. Do you know how to say fetch in French? Fetchers? It's fetchers. Arrange the polynomial in descending order. Okay? So this is what we call descending order. Okay? Can I just tell you guys that this is what's called math etiquette. Okay? Let's look up here. It doesn't make an answer wrong if it's not in descending order. But in the back of the book and on the exams, the polynomials will be communicated almost 99% of the time in descending order, without fail. And so we look at this. First of all, descending means to go from greatest to what?
Least.
To least or lowest, right? And, but by what? It's by degree of the term. And so, not by the big number, but by the little number. And so, if we have, let's take a problem like this. Let's take 2x to the third plus 12x to the fifth minus 7 plus 2x minus 8x squared. Okay? All right. Look up here, please. How many terms are in this polynomial? Come on, everybody, 5. If we're going to write this in descending order, what term comes first?
The biggest. The 12, 5, x 5.
12x to the fifth. Is that because the 12 is the biggest number? Or because the 5 is the biggest?
5 is
The
Because 5 is the biggest degree. So what's our next one?
2x third.
2x to the
2x to
third.
the third. Our next one?
Negative x.
Negative 8x squared. Then what?
Positive 2x.
Positive 2x
Negative
Minus
7.
and negative 7. Okay, very good. So that's descending order. G. All right. This is what we call the degree of terms in a poly and the overall degree of the poly. So the degree of a term in a poly, okay, so the degree of the term equals the sum of the degrees of the variables in each term, where the degree of the entire poly is not the sum, it's just the greatest degree of any one term in the entire poly, okay? Three points. Not bad. So, let's take this. Look over here. I want all eyes over here. Let's come over to this problem right here. I want you to join me. What's the coefficient, the degree of each term, and then let's talk about the degree of the entire poly. Okay. First off, let's go fast. Everyone, what's the degree of the first term? I'm sorry, what is the coefficient of the first term?
12.
12. Next one.
2.
2. Next one.
Negative
Negative 8. Sign before term goes with it. Next one.
2.
2. And?
Negative 7.
Very good. Okay. What's the degree of this term?
The
5.
5.
3.
3.
2.
2.
1.
1.
0.
0.
And then negative 1. No, this way.
No negative. 0. Okay. So I want you to look at the definition of the degree of a term. It is the sum of the degrees of the variables. Well, what's the variable here?
0.
There's no variable. There's no variable. So we could say this is x to the 0, because what's x to the 0?
1.
It's 1. And 1 times anything remains the
Same.
same. You cool with that? Now, do we need to write that there? We do not. I just wrote it there, but just to show you how come it's 0, okay? Because it's the degree of the variables. There is no variable there, so it's got to be to the 0 power. We cool?
Cool.
Okay, I'm going to put another one on the board. We're going to do this together. Look up here. I'm going to have 2x squared y. I'm going to have minus xy plus 4x minus 7. How many terms in this poly? How many terms?
4.
4. Good. Okay. What is the coefficient of each term? This one. 2. This one.
Negative 1.
Negative 1. This one.
4.
4. This one.
Negative 7.
Negative 7. Okay. Now, everybody, the degree of the term. Look up here. Look up here. It is the sum of the degrees of the variables in each term. So what's the degree of this term right here?
3.
Good job. It's 3. 2 and a silent 1 together make 3. What's this one?
2.
Yeah, 1 and 1 make 2. This one?
1.
Silent 1, 1. And this one?
0.
It's 0, just like the other, because that's like x to the 0. Cool?
Cool.
Finish writing all this down. I need to erase this middle board. You want to picture it? You want to do something? Do it right now, because I'm going to erase it. Okay?
Okay. You're thinking about doing groups, right?
Groups for poops.
So if we were to write on a shirt, we would have to graph out like points and all that stuff, right?
Yeah, it's a graph paper. Okay, can I erase the middle board?
Yeah, I just need to get closer with this.
You got it, man. But I can erase the middle board.
Well, with me, yes, is it? I'll check with everyone else.
Nah, man, they don't matter. It's just you, brother. Right? It's all about you. So you gotta tell yourself. Okay. Maybe. Not. You guys going serious on me today? You guys going serious on me today?
Of course not.
No.
We're just laser focused.
Laser. I like that. Okay. A, B, C, D, E, F, G, and H. Okay. H is our last one. We already got I. This one's called missing terms in Poly. I like to call this one weird. It's just weird. Okay. It's just kind of a different thing, and it kind of weirds students out a little bit. First thing that will help you is never do this unless told to. And there is a reason to do it. Here we go. So let's go ahead and, Alex, read that 12x to the 5th plus 2x to the 3rd to me.
12x to the 5th plus
Go fast.
2x to the 3rd minus 8x squared plus 2x minus x. I mean, minus 7. Sorry.
Okay, perfect. Okay, let's look up here for just a minute. So missing terms are basically missing degrees. Okay, so basically we start with a 5, we end with a 0. So what's missing in degrees in between? We have a 5.
4.
4 is missing. We have a 5, a 3, a 2, a 1, a 0, but the degree of 4 is missing. And so what we do is we hold the place by saying I have 0x to the n, and n is the missing degree. So what we're going to write here is we're going to rewrite this and call this 12x to the 5th plus, and then we'll write that we have, okay, 0x to the 4th, because how many x to the 4th do we have?
I don't understand what's missing. What's missing from the...
So look at degree. 5, 3, 2, 1, 0. 4 is missing in the sequence of 5, 4, 3, 2, 1, 0, right? Okay, that's it. So just looking at this, I am missing number 4. I don't have 4. I have a 3, I have a 2, I have a 1, I have a 0, but I don't have a number 4.
Got it.
And so I have no x to the 4th. So I say I have 0x to the 4th. So it's just a true statement. And then I write plus 2x to the 3rd minus 8x squared plus 2x minus 7, right? Everything else comes down, right? That's all you're going to do in this section. And why do we do this, okay? When we divide polynomials, we need placeholders for the missing terms. And so we got to know how to do this when that time comes, okay? Okay, that covers everything in section 4.3. Take pictures, do what you need to do. I am going to erase the middle board in about 10 seconds, okay? And I'm going to write a quiz up on the board, okay? I want you to get into groups, okay? And you got about to the count of 10 to get your chairs together in this group, all right? So let's talk about this, all right? You 4 right here. I want you to come over, Kyle, and join these 3, okay, over here. You've only got about 2 minutes to do all of these. You do them together, you talk to each other, and then I'm going to assign each group to go up and write an answer. You're just going to write the answers. You're going to do these problems. Go 2x to the 0, 3x squared times 4x to the 5th, x to the 4th x to the second, x to the 0. Let's see here, y to the negative 7 over y to the negative 12. Yeah, 5x to the negative 2y over z to the negative 3. What? P to the negative 5th over p to the 12th. Negative 3 p squared q to the 5th all to the 4th. All right, that's 1, 2, 3, 4, 5, 6, 7. Yep. Okay, that's our quiz for today. To do here is, if you can, write which law you're using as well of the 5 rules, right? You know, power, quotient, product, negative exponent, 0, whatever. Okay, I'm erasing this board. I like it. Okay, we're good. We're just going to jump in here. I want to teach you guys 2 more things. We're going to get out of here real quick. I want to review these. All right, so 2x to the 0. Obviously, x to the 0 is 1, so this 2 times 1, which we got here is 2. Awesome work. This is the 0 rule, okay? This is the 0 rule if you're just outlining rules, okay? 3x squared times 4x to the 5th. We get 3 times 4, which is 12. We're going to talk about that more in our video lecture for Friday. And then x to the 2nd times x to the 5th is x to the 7th, and that is the product rule, okay? Very good work, okay? Again, product rule, x to the 4 plus 2 plus 0 is x to the 6th. Awesome job. This is the quotient rule. It's going to be y to the negative 7 minus negative 12, which makes y to the negative 7 plus 12, which makes y to the 5th. Great work. Okay. This one is all negative exponent. Nothing has the same base. We're just changing some places here. However, really quick, and I appreciate you guys, because this is not the easiest problem. Watch this, please. The 5 doesn't come down. It doesn't have a negative exponent. It stays up top. Ready for this? And the y doesn't come down. It has a positive exponent. It stays there. And so this is why we do these things. It's okay. I love mistakes when we take quizzes because we learn more from our mistakes than we ever do from doing things right. Do you understand that? And that's why we came to Earth. We learn more from our mistakes than we do from doing everything right. I have kids, some of my kids, they get so frustrated when they don't do things perfectly. And I'm like, dude, like, it's okay. This is good. Please look up here. The z to the negative 3, that comes up to the top and becomes positive. That's correct. The x to the negative 2, that comes to the bottom. It's not the everything switches places rule. It's the negative exponents go to their opposite place in the fraction with their base and become positive rule. Okay? Okay. Good job. Okay? This one right here, this is actually a combo of the quotient and the negative exponent. Because you have p to the negative 5 minus 12, which makes p to the negative 17, which then you bring it to its opposite place. That's a good job. That's correct, okay? Really like that you got positive 81. Negative and a negative make a positive. Another negative and a negative make a positive. Negative 3 is going to be to the 4th power. P is going to be the 4 times 2 is to the 8th power. Q is to the 4 times 5 is q to the 20th. Then you can take that negative 3 and multiply it times itself 4 times. But can I just share something with you that I didn't share with any other class? If you don't multiply that out, the answer is 3 to the 4th, p to the 8th, q to the 20th. So if they didn't multiply that out, that negative 3 becomes a positive 3 to the 4th because it was taken an even number of times, okay? So sometimes the answer will be written like this. Sometimes they'll multiply it out. But just know that when you have an even exponent, that becomes a positive because the negative will cancel it out. And this is a simplified problem. And you ask, what's the objective? And the objective, when we don't have an equal sign, is to simplify. And the laws of exponents are simplification tools, okay? All right, look up here, please. All eyes up here. We're going to do that again, a couple of days. Okay, but look up here. In section 4.4, you're being asked to add and subtract polynomials. Really quick, I'll tell you this. In section 4.3, there's 101 problems. You're doing the odds, 51 of them. Very little work to show in most instances. You know 95% of it. Some of the stuff about the degree of the polynomial and stuff like that, you learned a little bit of new stuff. You're going to rock that. Section 4.4, we're gonna do every other odd because we already know how to do this. The addition and subtraction of polynomials, I didn't tell you that this is what it was, but I just taught you to distribute parentheses and combine like terms. Is this a poly?
Yes.
Is this a poly?
Yes.
What are we doing with them? If I go like this, what are we doing with them? Do you know how to add and subtract polys?
Yes.
You fetch and betcha. So let's come back to the subtraction here. Do you need this parentheses right now?
No.
No. There's no distributor. X squared minus 5x plus 6. Do you need this one?
Yes.
Oh yeah, that's got to go to here, to here, to here. Help me, go.
Negative 2x squared
Plus 7x minus 12. Okay, now do you have like terms?
Yes.
Yes, you got x squared and negative 2x squared make what?
Negative 1x squared.
Negative 1x squared, which we call negative x squared because we like to simplify things. Negative 5x and positive 7x make what?
2x.
Plus 2x, positive 6 and negative 12 make minus 6. We're done. Hard or easy? You already know how to do this. Okay, in all sincerity, really enjoyed myself in New York and appreciated you guys letting me take Monday off. Friday we were taking it off anyways because we were just going to get ourselves a little catch breath time. We got 3 weeks of school left, people. Okay, this is going to go by fast. We're going to do multiplication of polynomials in a video. It's one of the easiest lectures I teach. We usually get out of class 10 to 15 minutes early that day. I'm going to make about a 30-minute video, and you're going to be able to do that homework on Friday without coming to class. I'm sorry I'm going to miss Friday. I actually do want to be here, but this is a cool opportunity, and family's coming, and it just all just happened at once, and they're like, hey, we're coming, we're doing this. My kids are coming home to see her, all this stuff, so we're going to go do that. On Monday, we're going to complete the chapter and do 4.7 and 4.8. You're noticing in chapter 4, we're pairing up all the sections. Well, they just pair up nicely. And so that's why we're doing it. And we do it every semester. So Monday, we're going to complete this chapter. And then on Wednesday, we'll review and we'll open up another test next Wednesday, Thursday, Friday, Saturday. And then we have 1 chapter left, 2 weeks of school, and then we're done for the semester. So listen, okay, the light's at the end of the tunnel. I have this one bit of advice for you, okay? Don't give up, okay? Don't give up, right? If you're feeling fried and you're feeling like giving up right now, dude, the light is at the end of the tunnel. Keep pushing, keep kicking, keep pushing through because you're almost there, all right? Good luck. I will see you next Monday, okay? And yeah, thank you.